Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 43 of the Kubernetes Masterclass, and in this video we are going to understanding about the init containers in a Kubernetes. Imagine you are about to bake a cookies with your friends. Before you start mixing ingredients and baking, there are some important things you need to do first, right? So gather the ingredients. You need to make sure you have all the everything like flour, sugar, eggs and chocolate chips and whatever you need, and preheat the oven. The oven needs to be warm enough before you can bake anything. Clean the kitchen. It's good to have a clean workspace so nothing gets messy. These steps are crucial to make sure cookie making goes smoothly, right? So in the world of computers and apps, Kubernetes works kind of like that kitchen apps where like recipes are cooked up in a containers. So what are the init containers? Init containers are like those important steps you do before baking. They are like helpers that get everything ready so your main app can run perfectly. They run before your main app starts, do their job, and then go away. So in a simple way, you can understand. So if your application needs the database first, what init containers will do? So init containers will check that particular database is up and running or not. Okay, once this is up, okay, my Postgres is up and ready. Initialization is also completed. So if it's not, init container will do that particular initialization. You have to write some commands to check that particular condition that your Postgres or PostgreSQL SQL like that your database is up or not. So once then only the main application will work. In that case, init containers will help a lot. So why use init containers? So in a fun example, building a sand castle, init task, init containers what will do? Before you build a sand castle, you need to fill the buckets with sand and gather water to make the sand wet and sticky. The main task is once you have everything ready, you can start building your sand castle. That is the simple example you can understand. In Kubernetes, the init container fills the bucket with the sand and water, prepares everything like Postgres or whatever the database initialization and everything. Init containers will take care and it will check the services, okay, whether service is up or not. Then only the main container, the main app will run. That is the use of the init containers. Why we have to use the init containers? So preparation, they prepare the environment for your main pod or main application. Order matters, they make sure certain things happen before your app starts. Okay, some application needs the database first, then the main application needs it. So it will start the Postgres database first, then only the main application will start. At that time, you have to use the init containers. Safety, they ensure everything is set up correctly to avoid the problems later. So if your application is starting first and the Postgres starting later, what will happen? There will be some clumsy will be in between happens. So you don't connect to your database and the application not works fine. So at that time you can use the init containers, and setting up the configurations will take care in the init containers. And if you go to the kubernetes.io, here you can check it init containers simply. So init containers, this is one of the concept, and you can see that the this page provides an overview of init container, specialized containers that run before app containers in a pod. Okay, init containers can contain utilities or a setup scripts not present in the main app image. Init containers always run to completion. Each init container must complete successfully before the next one starts, the main one starts. So different from the regular containers and everything, you can read it from here. Using the init containers, init containers can contain utilities or custom code from setup that are present in an app image like that from sed, sed, awk like that. And we can check this one as well. Wait for the service to be created. So first of all, your application needs one of the service needs to be created. So we have to check that one. Okay, if my service is created or not. So if this is created, then only it will start the main application. If not, it will keep until check this one. This service is up or not in it container. So this is the simple example. You can see that. So this is simple pod specification YAML file. So what here my app container is doing. This is the container. This is main container. Okay, and these are the init containers. Init container means first init and initialization containers. So this will run first. These two containers will run first, then only this will be run. Okay, sh-c until ns lookup my service is up or not. If it's up, then only it will check the other one. Okay, my busy box, this will check, okay, my database is up or not. So if my service is up, then only it will check my database is up or not. If database is also up, then only it will run this particular container. Until that, this particular container will under pending state. It won't create, it won't start, and won't do anything. So whenever these two init containers successfully completes running, then only the main container will start. Okay. Here this particular container needs the database and service. So the init containers will take care of it. Okay, if the service is up, my database is also up. Okay, you can go and start running your application. This one. Okay, let's try to set that one. So here, let's see the running containers, get pods. So we don't have anything. So what I will do is I will use this example only, this one directly. I'll just copy this and I'll paste it pi1.yaml and paste it. And I don't have any services. You can see that. So my database and my service, these two services are not there. And I'm just creating one simple 1.yaml, and you can check that one as well. Kubectl get pods, no. Get svc, no. So this is the main cluster. By default, we will get this one, this particular service, and I don't have any services. So if I create this one, kubectl apply -f 1.yaml, okay, you can check that cat 1.yaml. This particular container, whatever is there inside the pod specification, it won't start before completing these two steps. Okay. So here there is no my service is created, no my DB is also created. So what will happen? Okay, if you see kubectl get pods, see init containers are not at running. And let's check the describe as well. Kubectl describe pod and enter. And if you come here, you can check this one as well. See init database my DB, and here init my service. So the initialize containers, whenever these are success, then only the main container will run. So until that, it won't run. You can see that successfully pulled the image. Okay, created the container init my service, started it, but it's not working fine. And if you check the pods, it will be under init state. And you can check that kubectl get logs directly, logs my app pod, enter. And you can see that error from the server, bad request, is waiting to start the under pod initializing state. Why? Because so if you want to see the specific container, you have to use this one init my service. I told this in the logs class. So you have to check the container logs of a specific container. You have to use -c init service. And you can see that ns lookup can't resolve my service. Default service is not there actually. It's waiting for the service. And if you check this one, uh, kubectl get pods, see it will under initializing state. So kubectl get svc also. See, there are no service. What we will do, we will create one simple service file here. Okay, this is the first one. What I will do is I will use this one, va2.yaml. So I am creating simple service here. The my service name is my service here. Remember that why we are using my service means, and if you come here, see here my service, right? ns lookup means it will check for this particular service name, my service dot default dot service cluster, like that. So that's why I'm creating the same thing here and come out of it and k apply -f. Before that, let's check the service again one more, svc. See, only one is there. What I will do, I'll apply the service. Okay, 2.yaml. My service is created. Okay, k got svc now, and you can check that my service is created now, right? If you check now, kubectl get pods, and you can see that one container is running because we created the one service. And if you see kubectl logs hyphen, okay, give the pod name first of all, my app, kubectl logs my pod hyphen c init hyphen my service, enter. And you can check that, see it's able to connect. Last day before that we don't have any service, at that time it's finding can't resolve. Now we created one service, it's able to connect. Okay, but here we still have another container is not running, right? We have to create one more service for that DB as well. So if you check this, my service is running. So if I want to see init db, okay, there is no db like that, init my db, okay. This container, this initialize container also needs to be run to start your container. If you check the logs, it will also say like that, see, waiting for my db. We are not created this service for my db, okay. Let's come again and create one more service, okay. This is the service for my db. Copy it and vi3.yaml, enter and paste it. See here I am giving the name is my db, okay. Come out of it, k apply -f3.yaml. It's created. K get svc. See, now I created my service and my db, and if I check pods, k get pods. See, my pod app is running now. It's not showing one by one init again because my two init containers are succeeded. And if I check the pod logs, okay, kubectl get logs -c init my db, it will also says, okay, okay, I have to give the pod name, sorry, get logs, that is wrong, logs and space my pod, enter. And you can see that last time we didn't created any service, that's why it's still waiting. So once it's created, it's able to connect to that service. So then only my pod is running, k get pods, okay. So this is the use of the init containers. Once the particular service is needed for that particular application is up and running or not, then only the main container will run. If you see the logs, okay, k logs, enter, and you can see that default container, this app is running now fine, right? So whatever we gave here, and you can see that echo, this app is running and it will sleep for 3600. So this is the use of the init containers, okay. I have simple example here I wrote. So here API version kind metadata, and here init container, you can check that BGBoss until ns lookup my service, the same thing. So until my service is up and running, okay, here what it will do, this is I explained everything. And deployment also we can use the init containers, okay. Here inside the pod template only we have to use this one, okay. Welcome to Nginx served by the Kubernetes. First of all it will run this one, okay, my Nginx is running or not, and it will check, okay. Deployment manages its replica and everything, and create the service Nginx and expose, okay. Let's try to use this one. Simple example of deployment. Copy it, pa4.yaml, enter, paste it. And here if you check a little bit, so API version kind metadata deployment replicas and everything. Here init container, what it's doing, echo HTML. First of all it's setting up the Nginx served by the Kubernetes. So and I will write here what I will do, I will go insert mode Mr. Cloudbook. So it will set this into my this one user share Nginx HTML index HTML. First this will set up this messages to this index.html. So once that is done, the main container will run and use this particular index.html. So whenever I see the output, it will give this one, okay, this message, welcome to Nginx served by the Kubernetes, okay. Come out of it, k apply -f4.yaml, it's created, k get pods, and you can check that pod is initializing, so it's creating, k get pods again. So that is done. And if you see logs, k logs and this pod, enter, and you can see that it started. So we don't see the output yet because we need to create a simple service as well to see the output, okay. Or we need to go inside. So I am creating simple node port one here, see node port 30007 and va 5.yaml. This is the node port service to expose my Nginx, okay. K apply -f 5.yaml, enter, k get svc. So Nginx service is created, k get pods. So here this is also created. So what I will do, kubectl get pods, I will do exec into it, k exec-it, and this one, and sh. Okay, we are inside it, cat slash etc, where we stored that particular file here, Nginx file. user share nginx HTML. Okay, cat user share nginx HTML and index.html, and you can see that welcome to nginx served by Mr. Cloudbook. This is the one. Init container added this one. Okay, this is how you can use the init container. You can use for the database as well. Okay, I hope you understand about the init containers and keep on supporting to Mr. Cloudbook channel.